If you're like most of us, you live in an older home in New England that was built before people ever thought about energy costs. But now we're all looking for ways to boost our energy efficiency and decrease those soaring costs of heating, cooling, and electricity, way down to, say, zero. Today we're talking to Sean Jeffords, owner of Beyond Green Construction in East Hampton. What he's doing may surprise and inspire you.
This house in particular, we're trying to take into account recycle, reuse. It's a 100-year-old building, for one, so we're recycling as much of that as possible while rebuilding it up in as energy efficient way as possible. And then we're going to pay attention to things like rainwater collection. We're going to be doing edible landscapes as well as recycled railings and just different things like that. Embodied energy. We're trying to recapture the energy that was originally put into the building and other components and reuse that as much as possible. So Sandy, this is traditionally how a concrete foundation is poured, where the panels are set into place on top of the footing. The concrete is then poured and the panels get removed. From there, we start with wood, and then what happens is that connection between the concrete and the wood becomes a weak spot, as well as the concrete itself has no thermal break. So if you took an infrared camera and scanned the concrete in the wintertime, you'd see how much heat is actually being lost through the concrete.
Ooh, not good.
Not good at all. So one of the ways to deal with that are these insulated concrete forms. Now what happens with these is you come right up from the footing and you can do either just a foundation or you can go all the way up to your roof with them. And this is a high performance wall assembly that these guys stay in place and the concrete gets poured and you get a complete thermal break with no air flowing through. I've always had a desire to be energy efficient. I've always shut off the lights after leaving the room, stuff like that. So as I kept learning more in the trades, just realized that the way that we build houses now isn't what it could be, and just looking at what's coming down the pike, me being an educator, homeowners depend on me to figure out what the best case scenario would be. So just knowing that, I started to further my education, taking courses here, there, and anywhere I could, just to try to figure out better ways to build. So Sandy, this is an educational tool that we use to talk about how ventilation is intended to work and what happens when it's not done properly. So this is the top of a roof that you would see normally, asphalt shingles or some sort of a roofing system. And this is the top side of a soffit where the air would traditionally be intended to flow up and in through the attic assembly. But what ends up happening is the air can get underneath the insulation assemblies, and at that point you're actually erasing heat, and we call that wind washing. So the way to prevent that and to remediate that is to take a rigid foam insulation and cut that around, stuff that in there, and air seal right in. So why don't we take a look at the inside of the attic, and I'll show you what it looks like from there.
Okay.
So this is the side of the attic you might not see too often, but this is just what we spoke of before with the rigid foam board placed just so and then foamed right in. At that point, we would then add the 16 inches of cellulose for the thermal boundary.
Great, great.
So if you'd like to take a look at down inside the bedroom, we've also taken away some of the wall assemblies to show how traditional fiberglass might perform versus like a cellulose, a dense packed cellulose, which can engulf all the different nooks and crannies as well as the wires, versus fiberglass. What you'll find is people don't stuff it behind there, so that can actually penetrate to the outside. The goal of this project is, in one sense, to be off-grid. We are going to keep our connection to the grid so that we can sell back our surplus, but the off-grid is actually going to represent our ability to be self-sufficient. We've got a supply of fresh food, water, heat, and electricity all produced on this site, so completely independent, so off-grid in that manner. It's going to be a zero energy design where the house is efficiently built to the point where it can produce as much as it consumes. So here we have a plot plan of our edible landscape and sustainable site design, where we're going to be incorporating the edible fruits, nuts, berries. There's going to be rain gardens, which are going to be used to control surface water runoff. We're also going to be storing the roof water runoff into a 12,000 gallon rainwater collection tank.
You're kidding.
And that's going to be used underneath this patio
Holy mackerel.
We're then going to irrigate the edible landscaping with a pressurized shallow well pump and feed it through an irrigation system. We're actually getting a really great reaction from the public. I mean, we've had a couple of open houses so far. Each time it's just a constant flow of people, 150 people in one day, and it's just like, people are not just like wondering what's going on, they're just ecstatic that there's actually options. You know, we can be independent. You know, this revolution can happen from the ground up, and we have the ways. It's just a matter of us working as a team to do it.
I hope you can see how even an old home that's been retrofitted for energy efficiency can cut back drastically on energy expenses and use. Benjamin Franklin said it best, "A penny saved is a penny earned." So go out and save those energy pennies and have fun. I'm Sandy Thomas. See you next time.